Hi, and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. The last time we met, we wrapped up our segment on prevalence estimates. In the next 3 videos, we're going to be doing some market basket analysis, which is also known as association rule mining. First, we'll do data cleaning, then data analysis, and then interpret our findings. So the question is, Jennifer, data mining is not a standard epidemiological methodology. We're looking at BRFSS data. Most people that use BRFSS data are epidemiologists. Why aren't we doing something like generalized linear models or binomial regression analysis? Why are we data mining? Well, as it turns out, I'm not an epidemiologist, and we didn't start this R for BRFSS series by developing really appropriate hypotheses, right? We didn't conduct a systematic literature review. We didn't work with a statistician or an epidemiologist to write good hypotheses. Our hypothesis is kind of a joke, that California girls would have better health than California boys. So because we don't know what we're doing, and I'm not an epidemiologist, I think data mining is something that will work for us. And actually, I think data mining is also kind of the future for big health data, because now we have so many different data sets available to us and so many new technologies and methods for exploring those data even without hypotheses, which can be kind of dangerous if unsupervised, but can also really lead to some unique discoveries that you wouldn't think of looking for if you were using predefined hypotheses. So we're going to be doing a market basket analysis. And today we'll start off by reading the article that I've selected for us to mimic our analysis from. We'll subset our data file again to match up with that article, and then we'll clean our data so that we'll be able to work with it in the next video when we do our analysis. The article I've selected is called Results on Mining NHANES Data, a Case Study in Evidence-Based Medicine. So let's start by tracking down that article. So we'll go to the internet. The article is called, I already forgot what it's called. Okay, I already have it here. Results on mining NHANES data. And we'll click on the first result. And you'll see, so this is in PubMed. The article is available from this website, but it's not publicly available for free. So I got access to this article through my university library system. So if you actually want a copy of the article, go ahead and message me and I'll send you my PDF copy. But if you don't have a subscription to some of these journals, you won't be able to get access. So if you press get access, it will make you pay $36 for it. So you don't have to do that. Just message me and I'll send it to you. So I have that article on my desktop. And the first question that we have for this article is The first question is, what is NHANES? All right, because we're working with BRFSS data. So NHANES, I think they describe it very well in this article. And obviously, you can search for NHANES in the internet as well, but that stands for the National Health and Nutrition Examination Survey. And it's another national health data survey, except they have 4 types of questions that they ask. So they have indicators and measurements taking physical exams. So these are clinical indicators. Their respondents undergo a clinical assessment. Results from laboratory analysis, so not just clinical like anthropometric measurements, but also blood tests, which result in these lab analysis, blood, urine, diabetes profile. They have a patient health questionnaire, which are just self-report answers, which these are the type of questions in BRFSS, which are self-reported answers. And then finally, demographic information, which is also contained in the BRFSS data set. So the benefit of NHANES is that it has a lot of clinical and laboratory data in it, which is really fantastic, really a lot more rigorous than kind of the solely self-report data from BRFSS. But the sample sizes on NHANES are much smaller, usually around, I believe, 40,000 per year. We'll check on that later. They actually have the numbers listed in this article. So regardless, it's much smaller than BRFSS, and they only release it every 2 years. So whereas BRFSS is collected every year, NHANES is only collected and released every 2 years. All right, and in this article, they actually combined 5 cycles of NHANES data. And actually, the number of respondents per year is only 10,000. So that's much, much smaller than the BRFSS data, which is 450,000 per year. All right, so we're just going to kind of thumb through this article and find the section that is most important for us for this tutorial. All right, so they describe NHANES here. In the next column, they describe how they combine their data sets. We're only working with the BRFSS California 2017 data, which we already have subset, so we don't have to worry about joining any data files. We can just jump over this. Here they describe the health indicators that they used to conduct their data mining. So they looked across these different health indicators. Something I really appreciate about this article is that next to each indicator, they list the question ID, or where that question can be found in the NHANES survey. So when we worked with the CDC surveillance summary, they didn't list the BRFSS question, which is really irritating for us because we had to match them up. But here, if we were working with NHANES, we could find direct matches. However, we're working with BRFSS, so I still had to go through the codebook and do some digging to find close matches, which I did. So let's open up the table where I did that. So these are the health indicators that they looked at. I've highlighted the ones in gray, or rather changed the text of the ones that didn't have direct matches in BRFSS to gray. Let me change that to black now so we can read it. So they looked at wearing a hearing aid, taking medication for high blood pressure, having shortness of breath, going to a community program or senior center for meals, diabetes, whether your mother smoked during pregnancy, whether as a newborn you were in the intensive care unit, if you have weak or failing kidneys, asthma, anemia, overweight, if you've ever had a blood transfusion, if you have arthritis, congestive heart failure, coronary heart disease, angina, heart attack, stroke, emphysema, bronchitis, liver condition, cancer, wheezing or whistling in your chest, if you've had a hysterectomy, if you have a sleep disorder, a current smoker, if you've been diagnosed with herpes, genital warts, gonorrhea, or chlamydia, and with contacts or glasses, how would you describe your vision? So the ones that I could find matches for in BRFSS are in this column. So we end up with the variable describing somebody who's deaf, high blood pressure, diabetes, chronic kidney disease, asthma, obesity, having arthritis. These two, congestive heart failure and coronary heart disease, are asked in the same question in BRFSS, so I just grouped them together. And actually, I misspoke. It's coronary heart disease and angina. So these two. Heart attack, stroke, emphysema, which is also in the BRFSS survey, is grouped together with bronchitis. So we're just looking at the one. Cancer. Oh, and then you'll see for some variables, I wrote module. That's because of the weighting, sampling weighting frame that we applied during the prevalence estimates videos. If you remember, we used the weighting variable called LLCP weight. And so that weighting variable only applies to the core questions. So even though there are some BRFSS equivalents to the NHANES questions, they are module questions. And so if we decide to move forward with these variables, we'd have to apply a different sample weighting frame, which is getting kind of complicated. So I just stuck with the core questions. All right, so when you see module, that means there was an equivalent in BRFSS, but it was not a core question. All right, cancer, smoking, and the question in NHANES is, how's your vision with glasses or contacts? The question in BRFSS is, are you blind? So it's kind of similar. And then just as we did in the prevalence estimates, we have to look at the values that we want to recode to 1. So, yes, I'm deaf. Yes, I have high blood pressure. 1, 1. Yes, I have diabetes. 1. Yes, I'm overweight or obese. We want to recode 2 to 1. All right, and then every other response we recode to 0. So if you're confused about what I'm talking about, go ahead and rewatch the prevalence estimate videos, because we're basically doing the same process here. So those are our health variables. Let's keep looking at the article. All right, next they describe the types of data mining techniques that they used. One of them was correlation-based mining, which we won't be doing, but that's the first one they did. The next one was association rule mining, which is what we'll be doing, which is also called market basket analysis. And then they also looked at, I skipped over it. Where did it go? At clustering, which we won't be doing in today's video, but I might revisit in a future tutorial segment. All right, so in this tutorial segment, we are doing association rule mining. And what is that? So when we think about health and health statistics, health prevalence estimates, we know from our last tutorial segment that a lot of people have chronic disease conditions and have poor health behaviors. But what we also know about public health is that a lot of people have kind of sets of chronic health diseases or poor behaviors. So they have comorbidities, right? They have a set of conditions. So what association rule mining does is it goes through your possible list of variables and looks not just for the frequency of each individual item, but looks for a set of items that is commonly occurring together across your population. So we call this an item set. All right, and why association rule mining is also called market basket analysis is because this method is used a lot in marketing research. So if you ever do online shopping and you start adding stuff to your cart, and then it gives you recommendations for something else that you might like, that's because the researchers that developed those recommendations looked across all of the things that everybody bought from that store, and based on what people are commonly purchasing together as an item set in their market basket, their online market basket, they make recommendations for you. All right, so that's why association rule mining is called market basket analysis. The only specification is that market basket analysis looks at things that do occur together, whereas association rule mining, you can look at things that do and don't occur together. So, you get a lot more rules with association rule mining, but with market basket analysis, you really narrow down to your variables of interest that actually do occur. So they give an example here of a rule. So this is an example of a rule. If you smoke daily and you don't exercise, those conditions are likely to occur with somebody having poor health. Okay, so the important thing about association rule mining is that you're looking for rules. So you're looking for this little arrow. So these conditions occur with this outcome. All right, is this making sense? This is what we're looking for. This is what we'll be doing. And some common metrics for association rule mining. When you think of traditional statistics, traditional epidemiology, you think about the p-value, right? You're looking for a statistical significance. But with market basket analysis, our kind of statistical metrics are called support, confidence, and lift. So support is the proportion of responses in which this item set occurred. So if you have 100 responses and you have an item set, a group of variables that occur together, if that occurred, for example, 10 times across your 100 responses, then your support is 0.1. So support is the proportion of observations in which that item set occurred. All right? And confidence is, when you're looking at a rule, it's basically the probability of these conditions occurring together with these conditions. So what is the likelihood of the conditions on the left-hand side of that arrow happening with the results on the right-hand side of that arrow? And then lift is another one. We're not using it for this article, so if you're interested in lift, just go ahead and search online. But we're keeping it to support and confidence because that's what they describe in this article. And something that I found really interesting about this article is that they describe this a priori algorithm, which is commonly applied in market basket analysis. And I've used the a priori algorithm in a market basket analysis on my own research, so I'm familiar with this. And I don't know the math or the science behind the development of this algorithm, but I've used it. And their argument is that a priori has been used a lot, but an extension of a priori called MS a priori was proposed that handles rare items and multiple support thresholds. So remember, support is the proportion of the proportion or the frequency of times that an item set occurs across your sample size. Their argument is that for health conditions, there are some really, really rare health conditions. So if you only set one support, your algorithm will only search for the frequency of that item set occurring at that support level. But for rare conditions, you would want to set a lower support level to detect variables that don't occur as frequently. So they propose an MS a priori algorithm, which they refer to, let's see. And the only implementation of MS a priori that they could find was referenced here at this website. So let's check it out. And the server is not found. So that's unfortunate, because I thought that was really interesting that they would want to set multiple minimum support thresholds, but that reference isn't there. So that's unfortunate for us, but then they do go on to describe how they improve upon this person's algorithm. So those are the next bullet points. They describe what they did, all of this, and then they start describing the results. And then finally, at the bottom here, right next to this website that we just went to where the link was broken, they also describe how they updated that algorithm. So if we click on this, we go to their university website, and we find that the topic doesn't exist. So that's unfortunate. We don't really have access to this MS a priori algorithm. And if we ask the internet about MS a priori in R, let's go to Stack Overflow, which is a really valuable website for troubleshooting your error messages in R. So Stack Overflow has a lot of information for when you get an error message. So let's check what they say. So this person asked a question about MS a priori and another variation called CAR a priori. And the answer was to load the A-rules package, which we will be doing in the next video. A-rules is association rules, and apply the a priori algorithm. So that was the response. And then the next person gave some other sample code to work from, but they ultimately concluded that I don't think that our implementations support multiple minimum support at this time. So basically, R can't handle MS a priori at this time. And that was posted in December of 2018, so fairly recently. We have one more thing that we can check on to make sure that we're not missing any opportunities to do this MS a priori algorithm. Let's look at the A-rules package in R. A-rules package in R. We'll click on the PDF file, open that up. So just as a test, let's search for a priori. We get a bunch of hits, 83, so that's good because we'll want to use that algorithm. But when I search for MS a priori, we get nothing. So we can basically conclude that in R, at least, it's impossible for us to do MS a priori. And we can't even really follow up on these links that the authors described. But we're still going to work from this article, and we're still going to apply the a priori algorithm. And what we're going to do instead of setting multiple minimum support thresholds is run our algorithm multiple times, incrementally decreasing the support threshold. So we start with our main, most frequently occurring item sets, and then we parse it down until we cast a really wide net to capture those more rare health variables that these authors describe are important to recognize. Because I think it's true. We should also search for the rare health conditions, but we just have to do it manually. So we can't use the MS a priori algorithm. But that's okay. The other thing that we will mimic from these authors is that they set their confidence to 0.5, which is basically, if I'm interpreting this correctly, that means that 50% of the time that the items on the left-hand side of the arrow occur, the items on the right-hand side of the association rule, so of the arrow, should also occur, right? So they're setting their confidence to 0.5, which we will also do. We just covered a lot. That was a lot of information. If you're new to data mining, I'm sure this is probably like information overload. Just stick with me. It will start to make more sense in the next tutorial and the one after that when we really start looking at the data. But for now, we've covered all of the important information, I think. We need to clean our data. So let's go ahead and open up a new R session. Set our crane mirror to the cloud. Set our directory to our desktop R for BRFSS folder. All right, and we're going to start with our California Girls 17 data file. We're going to, the data file that we subset today, we're going to call California Girls CG 17 _ DM for data mining. Put in the assignment arrow, read.csv, the name of our CSV file, which is California _ girls 17.csv, wrapped in quotes. Header equals true. Let's just glimpse that CG 17 DM to make sure that we have. I forgot to load the tidyverse. So call the tidyverse out of your library. And then you can call that glimpse function on this data file that we just read in. All right, so we have all 9,000 of our observations and all 240 of our variables. So what we want to do now is only select the variables from, and actually I should have named this data file. I shouldn't have put the attachment DM on it yet for data mining. I should have just kept it as this original data file name. But anyway, so we want to subset this original data file to just the variables described in that NHANES paper. So as you saw, I identified those variables in this Word document. Rather than typing out everything by hand, let me just walk you through this code and then we'll implement it, okay? So we're calling this data file California Girl 17 _ data mining. So we start with our California Girl 17 data file, which actually we called it something else. So let me just change that here. Data mining California Girl 17. So we're just going to retain that name and then change it here. California Girls 17 data mining. All right, and actually it's not really good practice to name objects the same thing, but since I forgot and I called this the file name that I wanted our subset data file to be, I'm just gonna rename it here and then call it the same thing here. All right, but usually you would call this something and then call this something else. All right, and what we had done previously when we subset our data file is we set an object, the keep var object, and then we wrote in our data file name. We did bracket, comma, and then minus, no, not minus. Then we kept the keep var, the variables in the keep var object, right? So that's what we did last time. This time, we're just going to take a simpler approach and use this function from the tidyverse called select. And this, by specifying select, we can also order our variables. So when we call select, we can tell R to set up our variables in this order and to keep only these variables. So we want to keep our sex variable because we're looking at differences between males and females. And these are the health variables described in the NHANES paper that have matches in the BRFSS data. So let's go back to R. We're calling it CG17_DM assignment arrow from our CG17_DM data file, which is our original California Girl 17 CSV file. Then, so we put a pipe. And in a previous video, I had said that pipe was parentheses greater than parentheses. Obviously, it's percent greater than percent. So this is our pipe, percent greater than percent. Now we call that function select, and then we'll go ahead and put in our variables. Let me capture all of them. All right, copy, back to R, put them in. I think I might have an extra parentheses in here. Yeah. All right, and I'll expand this window for you so you can see them. Make that a little shorter. There you go. So now we've subset our data file. Press enter. Let's take a glimpse. Glimpse, California Girl 17_DM. And now we have our 15 variables. So those 14 health variables from the NHANES paper, and then our sex variable. And as you can see, and as we know, R reads in the variables as integers. So now we have to recode these numbers to be like ones and zeros for the health variables and to be M and F for the sex variable. We also have to set the variable class to factor instead of integer. And this is the same exact process that we did when we were working with the prevalence estimates. So I'm just going to verbally walk you through it, but I've already written all of that code. All right, this is basically the same pattern of code that we used in the previous tutorial set. So we're changing our sex column to a factor and recoding where sex equals 1 to male and 2 to female. For this variable def, we're changing it to a factor, recoding 1 to 1, and setting everything else to 0. For this high blood pressure variable, we're setting it as a factor, recoding 1 to 1, and everything else to 0. And we do that for all of these. There are only 2 variables where the response that we want to recode to 1 is not 1, but it's 2. That's for this RF BMI 5 and this RF smoke 3. So this is overweight and obesity and current smokers. So we set 2 to 1 and everything else to 0. Let's just copy all of that code. And as always, I'll provide this code in the description for you. So you can just, go in and copy and paste it. But don't copy and paste it because actually YouTube doesn't let me put greater than or less than signs in the description. So anywhere there's an arrow, I indicate that by writing tilde, arrow, tilde. So you have to kind of clean up my code in the description, but once you do, you'll be able to just copy and paste it right into R. All right? So this is our code for cleaning our data. Let's just clean it. Looks like it all worked. Let's glimpse our data file again, CG17_DM. And now everything is set as a factor. Sex is MF for male and female. And the other health variables have zeros and ones for, whether they do or don't have that health condition. All right, so our data file is cleaned. What else were we going to do today? I forgot. That might be it. Yep, so we've read our article. we've learned about association rule mining. I hope I've kind of convinced you why it's okay for us to do data mining, because we don't have a true hypothesis. You know, it's kind of like we have a lot of opportunities to explore our data because we don't have a really rigid hypothesis to work from. So we're doing some data mining. We've cleaned our data file, and in the next video, we're going to install the association rules, or the A rules package, load the library, and start working with that A priori algorithm. So I'm not going to close out my R session now because I don't want to lose this data file which I've cleaned. So I'm just going to end the video here, and I'll see you back really quickly. So see you soon. Bye.